Okay, this is our third example of quadratic functions in standard form. This one is f of x equals minus x minus 1 squared. Okay, so this one opens down. The standard in standard form, it looks like a times x minus h squared plus k. Now on my problem, the problem that we're working on, I don't have anything over here. So if I add 0, then I haven't changed the problem. But I can see that there's k. K is 0 and h is 1. So my vertex, remember, is hk. So my h is 1 and my k is 0. That means that my range, since it opens down and is minus infinity to the k value, which is 0. The domain is all real numbers. The axis of symmetry is a vertical line. Vertical lines have the equation x equals something, and so the line of symmetry, or the axis of symmetry, line of symmetry, is always x equals h, at least for us in here, and so x equals 1 is the axis of symmetry. To do my y-intercept, I always let x equal 0, so I get minus 0 minus 1 squared. So I get minus, and then, so I get minus 1 squared, which is 1, and then I have this minus out here. So my y-intercept is minus 1. My x-intercept, I always let f of x equal 0 and solve for x. So I have x minus 1 squared equals 0, or I have a minus out front. So I can divide both sides by minus 1. And so that cancels the negatives on the one side. 0 divided by minus 1 is just 0. Now I take the square root of both sides. And so I get plus or minus the square root of 0. But the square root of 0 is just 0, and 0 is not positive or negative, so just get 0. The squares and square root cancel, so I get x minus 1 equals 0, add 1 to both sides, and I get x equals 1, and I only get one of them. That makes sense because my vertex occurs on the x-axis, the minus 1, or the 1, 0 thing, so that's my x-intercept. Okay, I should verify with my calculator. Remember to use the negative sign as opposed to minus, so negative x minus 1 squared. There we go. It opens down, and it looks like it touches there, so let me hit trace. X 0, y minus 1, that matches my y-intercept that I found. I get x equals 1. I get y equals 0, and that's my vertex. And so there wasn't much to do for that one.